The next chapter that we will be studying has to do with series and sequences, and we will be finding limits of series and sequences. But before we jump into it, this specific lesson is going to be about sequences. At the end of this lesson, you'll be able to describe a sequence. What exactly is a sequence? All right, a sequence is basically just a collection of terms. We usually have a first term, second term, third term. You are used to working with geometric sequences and arithmetic sequences from geometry. So I'm just going to give you a few sequences, and then I'm just going to give you a little taste of what we will be doing when we study sequences. All right, and a first example of a sequence would be 1, 1/2, 1/3, 1/4, and it would keep going. You'll notice there is a pattern to my numbers. The pattern is actually given by the formula 1 over n. Okay, so that is a sequence. What we're going to be doing with this is trying to figure out what number is my sequence approaching as n approaches infinity. So as the term numbers approaches infinity, what's happening? And if you can just look at this, 1/4, 1/5, 1/6, 1/7, the number is getting smaller and smaller, so it is actually approaching 0. And we will be saying, if we get something like that, that our sequence converges. We actually get an answer. All right, another example of a sequence would be 0, 1/2, 2/3, 3/4, 4/5, 5/6, and then we could keep going. The formula that would describe that sequence would be n minus 1 over n. And if you just look at that, if you look at our numbers, we're trying to figure out, as n approaches infinity, as I get more and more terms, what term am I actually getting closer to? And you'll notice the distance between the two, the fraction, is getting closer and closer and closer to 1. So the limit of this one would be 1. So we would say that this converges once again. All right, another example of a sequence would be the square root of 1, the square root of 2, the square root of 3, the square root of 4, and so forth. And the function that would describe this one would be the square root of n. We're just taking the term number and taking the square root of it. And if I wanted to find the limit of that sequence, where am I headed as n approaches infinity? This number is just getting bigger and bigger and bigger and bigger. So my limit is infinity. And if you can recall from when we did improper integrals, we would say that that would mean my sequence diverges. And one more example that I'll give you, I could have 1, -1, 1, -1, 1, -1, and keep going. And there actually is a formula that would describe that. That would be -1 to the n plus 1. And if I was looking at this limit as n approaches infinity, you'll notice there is really not a limit, because it's going to keep going back and forth between 1 and -1. It's actually not going to be approaching one number. So we would actually, in this one, say the limit does not exist. And so if it does not exist, we would once again say that this sequence diverges. So I just wanted to give you an example of where we're headed with this. We'll be looking at the sequences and trying to decide, does the sequence converge or diverge? And if it does converge, what does it converge to?